In this video, we are going to learn about binomial distribution. Binomial distribution is used to model situations where there are just two possible outcomes, which is success and failure. The probability of success is represented by P. The probability of failure is represented by Q. And probability of success plus probability of failure, which is P plus Q, is equals to 1. 1 is the total probability. The following conditions also need to be fulfilled. First, there must be fixed number of trials, which is n. The outcomes of each trial must be independent of each other. The probability of a success must remain the same for each trial. Each trial has two and only two outcomes, which is success or failure. And for binomial distribution, we must know that it is a discrete random variable, and we have formula to find the probability of success. The formula to find probability of success is Px equals to x equals to ncx times p to the power of x q to the power of n minus x, where n is the number of trials, x is the number of success, p is the probability of success, q is the probability of failure, which is 1 minus p. N for ncx is equals to n factorial or over x factorial times n minus x factorial, or we can just use calculator. And we write binomial distribution like this, where n is the number of trial and p is the probability of success. We have binomial table that we can use to find the probability, but we need to know that binomial table just give us the probability in the form of px greater equals to x, where x is the number of successes. For example, if we have n equals to 15, p equals to 0.08, we need to find px greater equals to 1. Remember, the table only gives the probability in the form of px greater equals to x. So, let's look at the table. We have n equals to 15 and p equals to 0.08. Next, px greater equals to 1. So 1 here, we look at here, the number 1, and the answer is this one, 0.7137. Next, if we have n equals to 20, p equals to 0.06, and we need to find probability of x greater equals to 4. Remember, the table only gives the value in the form of greater equal. So, n equals to 20, p equals to 0.06, and we need to find greater equal to 4. So, greater equals to 4. The answer is 0.0290. Okay, but since we can only find the value of px greater equals to x using the binomial table, so if we have in other form, we need to change the probability so that we can use the binomial table. For example, if we need to find px equals to a, so we need to minus px greater equals to a with px greater equals to a plus 1. Let's look at the example. Example, we have x binomially distributed with n equals to 15 and p equals to 0.05. Okay, we want to find what is the value of probability x equals to 3. So, if you need to find x equals to 3, okay, assuming we have a number line here, 3 and have 4, 5, 6 up until 15, because our n is 15. We want to find the value of x equals to 3. So what we need to do is p x greater equals to 3 minus p x greater equals to 4. Because if we have p x greater equals to 3, we will have the value from 3 to 4, 5, 6 up until 15. But we don't need the value x greater equals to 4, so we omit this value. So we only have px equals to 3. So look at the table given n equals to 15, p equals to 0.05, and px greater equals to 3 is here, 0.0362 minus px greater equals to 4 is here, 0.0055. So we have px equals to 3 is equals to 0.0307. Okay, next, if we have px less than equals to a, we will use 1 minus px greater equals to a plus 1. So let's look at the example. Okay, we want to find px less than equals to 2. So what we need to do is we will minus with something. So let's look at the number line. Okay, so we have 0, 1, 2, 3, 4, 5 up until 15, because our n is 15. We want to find the value of less than equals to 2. So that means we want to find the value of 0, x equals to 0, x equals to 1, and x equals to 2. So what we need to do is 1. Okay, the total probability 1 minus what we don't want, what we want to omit. So we don't want the value from 3, 4, 5 until 15. So 1 minus p x greater equals to 3. Remember, we only have greater equal sign in the table, so that's why we need to change the form. So 1 minus 0.0362. Okay, x greater equals to 3 is 0.0362 from the table. So 1 minus 0.0362 will get 0.9628. Okay, so the third one, if we want to find the value x between a and b inclusive, so what we need to do is px greater equals to a minus px greater equals to b plus 1. So let's look at the example. If we want to find probability x between 3 and 5, okay, so what we need to do is, first we look at the number line, 0, 1, 2, 3, 4, 5 up until 15. Then you want to find the value from 3 to 5. So we will have p x greater equals to 3, because the table only give greater equal value, minus what we don't want. So we don't want from 6 until 15. So px greater equals to 3 minus p x greater equals to 6. So from the table, we'll get px greater equals to 3 is equals to 0.0362 minus, from the table we'll get px greater equals to 6 is equals to 0.0001. So px, probability x between 3 and 5 both inclusive is equals to 0.0361. Okay, so that is the method to find the probability if we don't have greater equal. Okay, but remember, we can only use the binomial table if the probability is less than equals to 0.5 and n less than equals to 50. If we have p greater than 0.5 we will use another method to solve. We will look at the example after this. Next, we will look at the expected value, mean, variance, and standard deviation for the binomial distribution. For example, if we have x is binomially distributed with n as the number of trial and p is the probability of success, to find mean or expected value, here expected value or expectation, so the formula is Ex is equals to n times p. We just multiply n with p. Next, to find the variance, we will multiply n times p times q. And to find the standard deviation, we know standard deviation is the square root of variance. So standard deviation is equals to square root of n times p times q. Let's look at example 8. If n is binomially distributed with n equals to 10 and p equals to 0.1, find the value of probability x equals to 4. So from this question, we have n equals to 10 and p equals to 0.1. So from here, we can find q. Q is 1 minus p, which is 1 minus 0.1 equals to 0.9. So, to answer question A, probability x equals to 4, we can simply use the formula probability x equals to x is equals to ncx times p to the power of x times q to the power of n minus x. So, probability x equals to 4 is equals to 10c4 times 0.1 to the power of 4 times 0.9 to the power of n minus x, which is 10 minus 4 equals to 6. So, we can use the calculator. So, we'll get the answer is 0.0112. Now, let's look at question B. Find the probability of x greater than 2. So now, we will use binomial table, but before that, we need to change greater sign to greater equal, because binomial table only gives values for greater equal. So, if we have x greater than 2, that means 2 is not included. So, we will start our calculation from x equals to 3, x equals to 4, x equals to 5, up until x equals to 10, because our n is equals to 10. So, probability x greater than 2 is equals to probability x greater equals to 3. So now, we will look at binomial table page 6 with n equals to 10 and p equals to 0.1 with x equals to 3. Okay, binomial table page 6, n equals to 10, p equals to 0.1, so we will focus on this column. And now our x equals to 3, so this is the value of x. Then x equals to 3 is here, and the answer is 0.0702. Okay, so probability x greater equals to 3 is 0.0702. Now, let's look at example 9. Let x be binomially distributed with n and p equals to 0.22 and ex equals to 11. Find the value of n. So, for this question, first we need to know ex equals to np. So, what is ex? Ex is expected value or mean. So, we have one formula here. Expected value ex is equals to n times p. So, to solve this question, from the value expected value ex equals to 11, okay, just substitute the value of p we have here. This is the value of p, so n times p, n times 0.22 is equals to 11. Then n equals to 11 divided by 0.22, which is 50. So, now let's look at question B. Find the variance of x. So, for this question, we will use formula for variance. Formula for variance is n times p times q. So, variance x, we already have n equals to 50. Then, we just substitute p, 0.22. Next, to find q is equals to 1 minus p. So, 1 minus 0.22, which is equals to 0.78. So, to find variance, just multiply 50 by 0.22 and 0.78. Then we'll get 8.58. Question C. Find the probability of x equals to 4. So, we can use the formula. Probability x equals to 4 is equals to ncx. So, 50 c4 times p to the power of x. So, our p is 0.22 to the power of 4 times q, 0.78 to the power of n minus x, which is 50 minus 4 equals to 46. Then, use a calculator to find the answer. The answer is 0.0059. 0.0059. Example 10. X is a discrete random variable such that x is binomially distributed with n equals to 15 and p equals to 0.3. So question A, find the value of probability x equals to 2. So from this question, we have n equals to 15, p equals to 0.3, and q is equals to 1 minus 0.3, which is 0.7. So to answer this question, probability x equals to 2, we can use the formula. So probability x equals to 2 is equals to ncx. So 15 c2 times p to the power of x, 0.3 to the power of 2 times q to the power of n minus x, 0.7 to the power of 13. So, the answer is 0.0916. Next, question B. Determine the value of r if probability x greater than r is equals to 0.05. So we have from this question, probability x greater than r is equals to 0.05. So we know that if px greater than r, that means r is not included. So we will start with the number after r, which is r plus 1. So probability x greater than r is equals to probability x greater equals to r plus 1. And why we need to change from greater than r to greater equals to r plus 1? Because binomial table only gives the value for greater equal. So that's why we need to change from greater than r to greater equals to r plus 1. So now, let's look at binomial table, page 6. So this is the binomial table, page 6. We need to find Okay, so let's look at the question again. We have n equals to 15 and p equals to 4. We need to find what is the value that gives the probability 0.05. So n equals to 15 here, p equals to 0.3, so 0.3 is here, so we will focus on this column. So now we don't know which value here. This one we don't know, so we only have this one. So we will look at what is the value of x here that will give 0.05. So we need to focus on this column, which is the value of 0.05. So 0.05 is here. So what is the corresponding x? So the corresponding x, we will look at the row that gives 0.05. So from here, when x is greater equals to 8, the probability is 0.05. So probability from table, probability x greater equals to 8 is equals to 0.05. So this one, 0.05 is the probability. So we need to look at the value inside the table. Okay, so from table, probability x greater equals to 8 is equals to 0.05. Then we can just compare r plus 1 with 8. So r plus 1 is equals to 8. R is 8 minus 1, which is 7. Example 11. In a biology examination, 45% of the students passed. In a class of 20 students took the examination, find the probability that exactly 15 students passed. Before we solve this question, first we need to let x as the number of students that passed the exam. So we can use binomial distribution to solve this question with n equals to 20, p equals to 0.45. Why we can use binomial distribution? Because we only have two outcomes, whether the student pass or the student not pass the exam. Now we want to find the probability of x exactly 15. So we can use the formula 20 C 15 times 0.45 to the power of 15 times 0.55 to the power of 5. So that the answer is 0.004903. Next, for question B, find the probability that at least 2 students pass. So probability x at least 2, so x greater equals to 2. So we can straight away use the binomial table, page 7. So now we will look at statistical table, binomial table, page 7, with n equals to 20 and p equals to 0.45. So we will focus on this column. And now, from the question, we need to find probability x greater equals to 2. So probability x equals to 2. Here is x equals greater equals to 2. Then the answer is 0.9999. Okay, so 0.9999. So that's the answer. Please check binomial table, page 7. Okay, next question C. Find the probability more than 16 students pass. We still have x with binomial distribution n equals to 20 and p equals 0.45. So we need to find probability of x more than 16. To use the binomial table, we need to change more than sign to greater equal sign. So x greater than 16 means 16 not included, so we will start from 17. So x greater equals to 17. Again, let's look at the binomial table, page 7. So we need to find probability x greater equals to 17. We still use n. Okay, this is the value of n equals to 20, p equals to 0.45. So we want to find x greater equals to 17. Here is our 17. Then the probability is 0.0003. So 0.0003. Next, we need to find the probability from 3 to 7. So if we have the question from 3 to 7, that means the value of x is between 3 and 7, both inclusive. So to answer this question, we need to change probability x between 3 and 7 to greater equal. So okay, we draw a number line. We have 3, 4, 5, 6, 7, 8, 9 up until 20, because our n is equals to 20. Okay, we just want from 3 to 7. So what we can do is we will take probability x greater equals to 3. Okay, so if you want x greater equals to 3, this one 3 until 20, then we minus means we don't want. So what we don't want is from 8 onwards. So we don't want 8, 9, 10 up until 20. Okay, so x greater equals to 8. So probability x between 3 and 7 inclusive, or from 3 to 7, is equals to probability x greater equals to 3 minus probability x greater equals to 8. So let's look at our table with n equals to 20, p equals to 0.45. So we need to find probability x greater equals to 3. X greater equals to 3. So 0.9991, and probability x greater equals to 8. 0.7480. And always remember, binomial table only gives greater equal value. So from the table page 7, probability x greater equals to 3 is equals to 0.9991. Probability x greater equals to 8 is equals to 0.7480. So the final answer is 0.2511. Example 12. Professor Adam knows from past experience that 10% of his students will fail his exam. Find the probability that among 20 students taking the exam, none will fail. Okay, so before we solve this question, we will let x be the number of students that will fail the exam. So x can be binomial distribution with n equals to 20 and p equals to 0.1. Okay, so for this question, we can use binomial because we will only have two outcomes, whether the student fail or the student pass. Okay, now the question is find the probability none will fail. So that means probability x equals to 0. So we can use the formula 20C0 times 0.1 to the power of 0 times 0.9 to the power of 20. So the final answer is 0.1216. Example 12b, find the probability at most 8 will fail. So here we have at most 8, so that means the maximum number of students will fail is 8. So probability x less than equals to 8. Okay, to use the binomial table, we need to change it to greater equal sign. So let's look at this number line 0, 1, 2, 8, 9, 10 up until 20. Okay, so we know that we have x less than equals to 8, so this one. Okay, so we don't want from 9 up until 20. So what we can do is probability x less than equals to 8 is equals to 1 minus probability x greater equals to 9. Okay, now let's look at the binomial table with n equals to 20, p equals to 0.1. Again, page 7, n equals to 20, p equals to 0.1 here. So we will focus on this column. So probability x greater equals to 9 is here. So this is 9, the value of x. So this is the probability 0.0001. So probability x less than equals to 8 is equals to 1 minus probability x greater equals to 9, which is 1 minus 0.0001. So the final answer is 0.9999. Next is question 13. According to the Penang Education Department, 2 out of 5 students go to school by bus. Students are chosen at random from a school in Penang. Find the minimum number of students that must be chosen so that the probability that at least one student goes to school by bus is more than 0.9. So, for this question, first, we can define x as the number of students that go to school by bus. So, x can be binomially distributed with n equals to, we don't know yet, because that is what we need to find. And the probability of student go to school is 2/5. and we know that 2 over 5 is equals to 0.2. So I think it is easier if you write 0.4. Sorry, 0.4. Okay, now from this word until here, at least one student, probability at least one student, so x greater equals to 1, go to school by bus is more than 0.9. So for this question, what we need to find is what is the value of n so that px greater equals to 1 is greater than 0.9. Okay, so now what we can do is we will change px greater equals to 1 to 1 minus px equals to 0. Why we cannot straight away use the table? Because we don't know what is n. So we don't know which table or which page we want to use because we don't know what is the value of n. So we will change x greater equals to 1 to 1 minus x equals to 0. Because we want from 1 up until n. We don't want x equals to 0. So that's why we use 1 minus px equals to 0. So 1 minus px equals to 0 greater than 0.9. Rearrange so that we have px equals to 0 less than 0.1. Please be careful with this inequality sign. We change it to less than because we have negative. Okay, so note here from this line we have 1 minus px equals to 0 is equals to greater than 0.9. So if we move the 1 there, so we have negative px equals to 0 greater than negative 0.1. So we want to omit the negative. We need to change the sign to less than. Okay, so that's why we have the below line. Okay, so from here we have px equals to 0. We can use the formula, but we don't know the n. So nc0 times 0.4 to the power of 0 times 0.6 to the power of n. Okay, nc0 is equals to 1. 0.4 to the power of 0 is equals to 1. So what we have left here is 0.6 to the power of n less than 0.1. Okay, next, log both sides. So we'll get n log 0.6 less than log 0.1. Then use your calculator to find n. So we will have the sign here is greater than. So n greater than log 0.1 over log 0.6. Why we change less than to greater than? Because log 0.1 is a negative value. Okay, log 0.1 is a negative. Log 0.6 also negative. So if you want to omit the negative from n, you need to change less than to greater than. So use your calculator, you'll get n greater than 4.45. Since n is number of students, so n has to be an integer. So n equals to 5. Finding the probability of obtaining y number of failures when given p is less than equals to 0.5. We can use binomial table only if the values of p is less than equals to 0.5 and n less than equals to 50. But sometimes the question asks to find the probability of obtaining y number of failures, which is the other outcome. So in this case, we have to change the number of failures y to the number of successes x in order to use the given value of p. Example 14. Public opinion reported that 10% of Malaysians are afraid of being alone in a house at night. If a random sample of 20 Malaysians are selected, find the probability that A, exactly 15 people did not afraid of being alone at night. So before we solve this question, first we need to let X be the number of people who are afraid of being alone at night. So we can let X be binomial distribution with n equals to 20 and p equals to 0.1 from this sentence. And we can let X be binomial distribution because we can only have two outcomes, whether the person is afraid or not. Okay, so let's look at the question. The question tells us to find the probability that exactly 15 people did not afraid. So from n equals to 20, we have 15 people did not afraid. So since we have let our distribution X as the number of people who are afraid, so we need to find from 20 people, if we have 15 did not afraid, so we only have 5 people afraid. Therefore, we need to find the probability X equals to 5. So when Px equals to 5, we can use the formula 20C5 times 0.1 to the power of 5 times 0.9 to the power of 15, which is equals to 0.0319. Next, the second question, find the probability that not more than 17 did not afraid of being alone. So here we will use the probability. Okay, so we have the total, or the number of trial, the number of people is 20. Okay, we have X as the number of people who are afraid, and we will let Y as the number of the people did not afraid. Okay, if we have not more than 17, that means that the maximum number is 17, which means 17, 16, 15, 14, and so on. So from 20 people, the total 20 people, if you have not more than 17 who are not afraid, that means we have 3 or more people who are afraid. 5, 6, 7, and so on. So if we have not more than 17 did not afraid, that means that we need to find probability X greater equals to 3 people who are afraid. So we will still use this table, n equals to 20, p equals to 0.1. Okay, so from the table, Px greater equals to 3 is equals to 0.3231. Next, question C. At least 16 people did not afraid of being alone at night. Okay, again, we have the total number of people is 20. The number of people who did not afraid is at least 16. That means the minimum number is 16. So 16, 17, 18, up until 20. Okay, remember the total number is 20. Then if we have 16 people did not afraid, that means we have 4 people afraid. Okay, X is number of people afraid. So if we have 17 did not afraid, which means we have 3 people afraid. If we have 18 did not afraid, 2 people are afraid, because we need to complete the total, that is 20. So until 0. That means for Y greater equals to 16 for did not afraid, so we need to change to X, because we have let our X be the number of people who are afraid. So we need to find probability X less than equals to 4. Then we will use the binomial table with n equals to 20, p equals to 0.1. But you need to remember the table only give the greater equal value. So for probability X less than equals to 4, we need to change it to 1 minus probability X greater equals to 5. So using binomial table, n equals to 20, p equals to 0.1. For px greater equals to 5, we'll get 1 minus 0.0432. So the answer is 0.9568. Probability of success P greater than 0.5. The binomial table only gives values of P less than or equal to 0.5. For values of P greater than 0.5, we have to use the following guide in order to use the binomial table. If we have Px greater equals to X, for X binomially distributed with n and P, so we need to change it to Y. Y is still binomial distribution, but we use the probability is Q, which is 1 minus P. So if we have X greater equals to X, we need to change it to Y less than equals to n minus X. We can see that the inequality sign will change from greater equal to less than equal. Similarly, if we have Px less than equals to X, for X binomially distributed n and P, so we need to change it to Y greater equal n minus X. For Y binomially distributed n 1 minus P, which is Q. So if we have Px equals to X, for X binomially distributed NP, so we change it to Y equals to n minus X. For Y binomially distributed n 1 minus P. To do this, we need to change the definition of success into a failure, which means that instead of we use P, we will use Q, and if we want to use Q, we need to change it to P. Okay, so let's look at example 15. If 80% of the people in a community use the emergency room at a hospital in 1 year, 80% use the emergency room in a year, find the probability below for a sample of 10 people. Not more than 3 people use the emergency room. So before we solve this question, first let us define X. So X is the number of people in the community use the emergency room. So we can use X as binomial distribution because we only have 2 outcomes, whether the people use or not use the emergency room. So binomial with n equals to 10, p equals to 0.8. As we can see here, p is 0.8. This is greater than 0.5. Again, if you want to use the table, P must be less than equals to 0.5. But here we have P greater than 0.5, which is 0.8. So we need to change to Y with the number of people. Y is the opposite of X. If we have X, the number of people use the emergency room. So for Y, we will use Y as the number of people who did not use the emergency room. Okay, Y is the opposite of X, did not use. So if we have X with N equals to P, N equals to 10, P equals to 0.8. So for Y, still binomial distribution with N equals to 10, the number of people or the number of trial N is still the same, but instead of we use P equals to 0.8, we will use Q 1 minus 0.8, which is 0.2. So now we have the probability here is less than 0.5. So we can use table. Okay, now after we define our distribution, we will look at the question. Not more than 3 people use the emergency room. So P X not more than 3, so 3 is the maximum, less than equals to 3. Why we use X? Because the question states that the people use. So if the people use, we will use X. Okay, so we have P X less than equals to 3. If you want to change it to Y, less than equal will become greater equal. Okay, instead of 3, we will have here N, which is 10, minus 3, which is 7. So Py greater equals to 7. Using the table, page 6, with N equals to 10, P equals to 0.2, for Y greater equals to 7, we'll get the answer 0.0009. Okay, that is question A. For question B, at least 4 people use the emergency room. Again, we have the keyword here, use, so which means we have the variable is X. At least 4, the minimum number is 4, so X greater equals to 4. But we cannot use table because for X we have the probability is greater than 0.5. We need to change it to Y. So if we have less than, we have greater than equal. For Y, we will have less than equal. If for X we have 4, so for Y we have 10 minus 4. 10 is the value of N. So 10 minus 4, which is 6. Okay, so we can now refer table page 6 again with N equals to 10, P equals to 0.2. But then the table only gives value greater equal. So P probability Y less than equals to 6 is equals to 1 minus probability Y greater equals to 7. So we have probability Y equals to 7 from part A, 1 minus 0.0009. So the answer is 0.9991. Okay, 0.9991.